So this is problem 7 of the Aime. Ed has 5 identical green marbles and a large supply of identical red marbles. He arranges the green marbles and some of the red ones in a row and finds that the number of marbles whose right-hand neighbor is the same color as themselves is equal to the number of marbles whose right-hand neighbor is the other color. An example of such an arrangement is GGRRRGGRG. Let M be the maximum number of red marbles for which such an arrangement is possible, and let n be the number of ways he can arrange the m plus 5 marbles to satisfy the requirement. Find the remainder when n is divided by 1,000. So let's say you have might want to use different letter. Let's say you have x red marbles in a row. So the number of marbles with whose right-hand neighbor is the same color is n minus 1, and those with opposite colors, of course, is 0. So if you insert a green marble between 2 red marbles, then the ones with the opposite color increases to 2, and since you now have n marbles who have right-hand neighbors, these ones with the same color neighbor become n minus 2. And so every time you add a green marble between 2 red marbles, the number of marbles whose right-hand neighbor is the opposite color increases by 2 for the green marble just added and the red marble to the left of it. And then the number of marbles whose right-hand neighbor is the same color decreases by 1, and that 1 is, of course, the red marble to the left of the green marble just added. So this is 1 green, this is 2 green. So if you continue the pattern to 5 greens, you get that opposite equals 10. Wait, 2. Sorry, this is 0 green and this is 1 green. So if you go to 5 green, yes, the opposite is 10. And then the same would be n minus 6. And at this point, you have the maximum number of those with opposite colors because you put the greens in such a way that none of the greens touch each other. So since the opposites equal the same, 10 equals n minus 6, which means n equals 16. So that means there are 16 red marbles and 5 green marbles. So there are 16 red marbles, and the green marbles can be placed in any of the 15 spots between the red marbles. So the answer to this, the number of ways to arrange them is 15 choose 5, which is equal to 15 times 14 times 13 times 12 times 11 over 5 times 4 times 3 times 2 times 1. So this cancels. That, and this becomes this. So then we have, so this becomes 21 times 143, which will become 1430, 28, 60 plus 143, which is 3003. And since we want to find the remainder when we divide by 1,000, the answer is 3.